All right, sixth graders, we're going to learn a little bit about distance time graphs versus speed or velocity time graphs. And so first off, let's discuss distance time graph. So a distance time graph is a graph that is going to show speed of an object. It's going to show the distance it's traveled over a certain amount of time. So reading in information on the graph. So as you can see, this is a situation where there's a black car and a blue car, both of which start at a different position. Okay, so the graph lines are parallel. Both cars have the same constant speed or velocity. Okay, how can you tell this? Because the angle or the slope at which they're both moving is the same. Alrighty, so constant speed means a straight line essentially. Okay, and anytime on a distance time graph you see a line go horizontal like this or like this, that means that they are not moving. Their displacement or their position is not changing. This car is at 30 meters. It isn't still, it's still at 30 meters, 30 meters, 30 meters. The only thing that's changing is the time at which it's sitting there. Okay, you can tell that the car is motionless or stationary because the distance or the position or the displacement is zero. That means its speed is zero, because zero divided by anything is zero. Okay, so let's take a peek at an example. So here's a different graph. Same situation, blue car versus black car. They're both starting out at the same constant speed, different positions. They're both moving with the same speed upward because their slope is the same. However, the black car stops here, which then allows the blue car to pass the black car, and then the blue car stops about, looks like 5 meters further than the black car. Okay, so how do we know that's happening? Okay, that's happening because as it's moving past this displacement, it's now further away. Okay, it has traveled farther than the black car, and it's stopped because it's horizontal line. Alrighty, here's another situation. A new motorcycle. Your friend just bought a new motorcycle and wants to show it off for you. Look at the graph below and see if you can describe the motion that's taking place. So, looks like they hopped on the motorcycle. They drove away at a constant speed, a steady speed. Then they stopped the motorcycle about, looks like 30 meters away. Stopped the motorcycle. And then, as you can see, this line's going down. Now, does that mean it's not moving? Nope, they're still moving. It just means that they're coming back to where they started from. Okay, so think of this in a distance time graph. Think of this zero is the motion detector, so to speak. So the motion detector is sitting right by the motorcycle. They hop on the motorcycle, they drive away from the motion detector. They get 30 meters away, they stop. Maybe they turn around. Actually, they definitely turn around. And then they come back to where they started, right next to the motion detector. Okay, so they're moving away, they stop, then they come back to this to where they started from, or their motion detector. Okay, now here's a question for you. At which point in time were they moving faster? When they left or when they returned? Look at the lines to determine. The steeper the slope, the faster they are traveling. So this one's is steeper than this one, therefore it's going faster. Okay, think of it as if you're going to ski or snowboard or tube down a mountain. This one is a steep mountain. This would go very fast. This is a not as steep mountain, not a steep slope, so it'd go a little slower. Okay, so the segment A to B is going away from the motion detector at a constant speed or velocity. Segment B to C, your friend has stopped moving. They're not moving whatsoever. And then now your friend is returning to you from C to D. Alrighty. And you can calculate the slope or the speed of that object by looking at each of the lines. So from point A to point B, 30 meters minus 0 meters is 30 meters divided by 3, it looks like. It's 10 meters per second. B to C, 30 meters minus 30 meters is 0. 0 divided by anything in the whole wide world is 0. Your friend is motionless, stationary. And in this one, 0 minus 30 is not a negative 30. 0 minus 30 is 30 divided by, looks like 5. 30 divided by 5 is 6. next is negative 6 meters per second. Oh, shoot, I forgot to, yeah, this is a negative 30. Sorry, my bad. Negative 30 divided by a positive 5, which gives us a negative 5 meters per second, which is determining that it's coming back to 0. My bad on that one. So interpreting those graphs, we already did that. And that's it for this one. That is distance time graphs and how to read them.